So let's read the question. Based on the given figure, so we're given a right angle triangle PQR, right angle at Q. We have to find tan of P minus cot of R. Now if you notice in this figure, only two sides are known to us. To find any trigonometric ratio, we basically need all the three sides of a triangle. So first step is find the third unknown side. Now how do I get the third unknown side? Right angle triangle, two sides are known to me. Third side, Pythagoras theorem. So first of all, we'll apply Pythagoras and get the third side. So in triangle PQR, Pythagoras, square of the hypotenuse is sum of the squares of the two sides, which is the hypotenuse. I'll label it side opposite to the 90-degree angle. So PR over here is the hypotenuse. So square of the hypotenuse, that means PR square is equal to sum of the squares of the other two sides. So PQ square plus QR square. Pythagoras theorem. So do mention it over here. Pythagoras theorem. So next, let's plug in the values. So PR square, meaning 13 square, is equal to PQ square, that is 12 square, plus QR square. So let's solve this. 13 square, 169, 12 square, 144, plus QR square. Bring 144 over here. So 169 minus 144 is equal to QR square. 169 minus 144, 25 is equal to QR square. So QR is basically square root of 25. So from here we get QR is equal to 5 centimeter. So I'll mark it over here. QR is 5 centimeter. Now that we have all the three sides of the right angle triangle, we just need the trigonometric ratios. So let's begin. First we need tan of angle P. So tan of angle P, definition of tan, it is perpendicular by base. Now be very careful over here. First of all, identify the angle tan of P. So mark this angle. Now with respect to this angle, which is perpendicular, which is base? Remember, perpendicular side opposite to it. So for angle P, which is perpendicular, side opposite to it, QR. So QR is perpendicular, which is the base, side adjacent to it. So PQ is the base. I repeat, this is very, very important. With respect to angle P, which is perpendicular, which is base. So for angle P, perpendicular side opposite to it, QR, base PQ. So what is QR? It is 5. So QR is 5 upon PQ, that is 12. Is this clear? Next we need cot of angle R. So cot of angle R. What is cot? It is basically reciprocal of tan. So it is base by perpendicular. Next. Now here we have a different angle. I repeat, here it is angle P, here it is angle R. So mark angle R. Now with respect to angle R, which is the base and which is the perpendicular? See, for angle R, perpendicular side opposite to it. So side opposite to angle R, PQ. So PQ is the perpendicular, side adjacent, QR is the base. So QR is the base and PQ is the perpendicular. I repeat once again, for angle R, which is perpendicular, which is base. So you already have the hypotenuse, just get the perpendicular. Perpendicular means side opposite to it. So side opposite to R, PQ is the perpendicular, whichever side remains is the base. So this remains, this is the base. So QR is the base and PQ is the perpendicular. So what is the value of QR? It is 5. Value of PQ, that is 12. Is this clear? Now we'll evaluate. So tan of P minus cot of R is equal to tan of P, 5 by 12, cot of R, 5 by 12. So when you solve this, you get 0 as the answer. So this over here is the answer. So this is how you solve this question. So remember, the first step is get the three sides of a right angle triangle. How? By Pythagoras theorem. Then get your trigonometric ratio. First write down the definition. Be very careful for which angle it is. For angle P, which is the perpendicular, QR, which is the base, PQ. For R, which is the perpendicular. Remember, perpendicular is side opposite to it. So for R, perpendicular side opposite to it, PQ. This is the perpendicular, this is the base. Is this clear? So get 10 P cot R, plug in the values, we get the answer 0. So this is how you solve such type of questions. I repeat, be very careful for which angle you're finding the trigonometric ratio. Right? So this is how you solve this question.